Oh my goodness, we have a box. It has finally come, a box question. So questions about geometry, simple boxes and shapes is super common in Year 12 algebra because it lends itself to quadratic equations, right, which is a big part of this course. So what do we have here? We have a rectangular box, right, a cuboid, but it has no lid. No lid, right? So it's not a present for you, sadly. The length of its base is 60 centimeters. Its height is a quarter of the sum of its width and length. Okay, so we're given a bit of information here, and then the total area, so the base and the four sides, note it excludes the top because there's no lid. That area is 7,400 centimeters squared. And our task is to find the height. So just looking at what we know this length, but we don't know the width or the height. Of course, this is the height still, this is the height, this is the height, that's the width. There's 60 centimeters back there too, because it's a rectangular box. And we're given some information about the area. So our first task is to write down some equations relating these variables, combine them, so that we can then solve for height. So let's start with this one here. Its height is 1/4 of the sum of its width and length. So its height is equal to 1/4, 1/4, of the sum of its width and length. So the sum of its width and length. Okay, so this expression inside the brackets is the sum of its width and length, right? We don't know what width is, but we do know the length is 60, and the height is a quarter of that. So when we say a quarter of something, that means times. And in algebra, when we write a number outside a bracket, we're implying that there's a times there. So we don't actually need to write it. But if you wrote that, that is perfectly fine too. But the brackets there are important. Right? This is different to that, because we'd be doing a quarter times the width, and then onto that we'd add 60. But here we want a quarter of the sum of the width and length. So we need to add that first, which we show by using brackets. Wonderful. So we already have an expression. Is that enough to find the height though? Right, so we have one equation, but we have two unknowns. So we need to go further. What other information can we use? We could use the area, right? This third bullet point. So let's find an expression for the area in terms of W and H, and then equate that to 7,400, right? So the area, let's do the base first. So that area of the base is width times 60, right, or 60W. And we don't add the area of the lid, right, because there is no lid. And now the area of the left and the right side is W times H, right? Remember, this is still H here, this height. So W times H, and we have two of them. So we can just multiply that by 2, right? 2 of them. And then let's look at the front face. So the front face here, height H, length 60. So that will be 60H. But again, we also have the one at the back with the same dimensions. So we'll times that by 2, which gives us 120H. And we know that the area must equal 7,400. So what we've done now is we have two equations and two unknowns. So W, the width, and H, the height. And whenever we get to a place where we have the number of equations is equal to the number of unknowns, we can solve it. So that's a good indication we're almost there. How you solve it, lots of different ways. I'll show you one of them. It's called substitution. So solve by substitution. And that's where we take one of the equations. So I'll take this one up here, equation 1. And whenever I see an h in the second equation, I will be replacing it with this. Right, because h is equal to 1/4 times w plus 60. So I can replace the h with that expression. So we will substitute equation 1 into equation 2. So equation 2 becomes 60w plus 2wh, where h is 1/4 w plus 60. Don't forget our brackets there. Plus 120h, where h again is 1/4 w plus 60. And all of that, remember, equals 7,400. So again, we just substituted the first equation into the second, and now we have this big long equation that we can simplify down and then solve for w. So let's do that now. So 60w plus. Now, to simplify this, these are all multiply, so it doesn't matter, well, apart from this expression. So let's do 2w times 1/4, which is 1/2 w. And then that's all times w plus 60. And here, 120 times 1/4, that's 30. And we're left with the w plus 60, all equals 7,400. Now 1/2 w times w is 1/2 w squared. 1/2 w times positive 60 is plus 30w. We have another plus 30w. And then we have 30 times 60. What is that? 30 times 60, 1800. I should have done that in my head. Equals 7,400. Now we can group like terms. And you'll notice we have a w squared term as the highest power. So this will actually simplify to a quadratic. So I'm going to write it in standard form. And what that means is I put the w squared term on the left, and then the w term, and then the constant equals 0. So the w term, we have 60 plus 30 plus 30, which is 120w. Then we have 1800, and I'll minus 7,400 from both sides, which gives us minus 5,600. All equals 0. So getting to this point is a very good step. We have a quadratic equation in terms of w, and we can then solve for w. So to solve this, I'm not going to waste my time factorizing and yada yada. I'm going to go menu, equa for equation, polynomial, so f2. So I'm solving a polynomial of degree 2 because it's a quadratic. And we have 1/2, so 0.5, 120 for B, and minus 5,600 for C. So that's just these coefficients here. And I hit solve F1 to give x equals 40 or negative 280. but in this case it's W, so W equals 40, or W equals negative 280. Wonderful. So we found the width. Well, we have two solutions for the width. Which one do you think is the valid solution? Right, in this case, we will take the positive solution because it's a dimension. So the width is 40 centimeters. But the question has asked us to find the height. So we can use our relationship relating, well, either relationship relating width to the height. I will use the first equation because that's simpler. So that's where we substitute in the height equals a quarter times the width, where we know the width is 40, plus 60. Right, so I'm using equation 1, and I just substituted in the width. And that simplifies to a quarter times 100, which gives us 25 centimeters. So the height of this box is 25 centimeters. That's a decent sized present, maybe your lunchbox. I'm getting hungry now, so I'm going to go eat lunch.